Nick is Principal Waterways Engineer with GHD in Perth. And Nick is going to talk to us about groundwater management near water-dependent ecosystems. Thank you.
Good morning. My name's Nick Deeks. I work at GHD, and I'm going to be talking about groundwater management near groundwater-dependent ecosystems. So, firstly, what are groundwater-dependent ecosystems? They are systems that rely on groundwater to survive. So that's such as lakes, rivers, and creeks with groundwater base flow, wetlands, karstic and cave systems, and estuarine systems. Now, these ecosystems rely on maintenance of the natural hydrologic cycle, including the maximum and minimum seasonal water levels and the associated range of inundation with that, the duration of the wet and dry periods, the surface water and groundwater inflow and outflow rates, and what water quality levels go through that system. In other words, these are the ecological water requirements. So how do we determine what the ecological water requirements are? Well, the level of an ecological water requirements investigation will need to be undertaken, but the level of detail of this investigation really depends on the environmental values of the groundwater dependent ecosystem that you're looking at. If it's a highly degraded wetland or a wetland categorised as resource enhancement, there may be no need for the investigation. It also depends on the type of development and the associated risk, the size of the development, and the availability of existing monitoring data. So the first step in the process is to do an environmental assessment and characterisation of the subject land. This step is normally undertaken as part of the usual site assessment process. The second step is to identify the potential water-dependent ecosystems and their conservation significance. Step 3 is to identify the ecological objectives for the water-dependent ecosystems. And step 4 is to identify the current water regime. This may involve collecting and reviewing groundwater monitoring data, surveying wetland transects, and monitoring any surface water inflows and outflows. Depending on the complexity of the system, this information may be used in a hydrogeologic model to understand the water movements. So what groundwater management strategies are suitable for your particular site? So first, the factors to consider in the groundwater management strategies are firstly the clearance to the groundwater. So are you after a particular classification of your site? Does council have any requirements? What sort of road and structure and foundation requirements are there? And what sort of amenity of the lot do you want to produce? Are you willing for the waterlogging, for there to be waterlogging of the gardens in the future if there's a particularly wet year? And also soil types. Is it sand, clay, silt, laterite, rock, something else, or maybe a combination of these? And what sort of land use is proposed? Is it residential, rural residential, industrial or commercial? And what sort of stormwater and wastewater management is going to be in place? Are you going to use soak wells and septic systems or ATUs? So I'm now going to present a number of different groundwater management scenarios. The list is not exhaustive, but it covers many situations that face developers in WA. The first group of scenarios is based on development in a sandy site near a groundwater dependent system in an unconfined aquifer. The figure here shows the extent of the groundwater dependent ecosystem as identified in the EWR investigation, and I've illustrated the maximum groundwater level. So just a disclaimer, the solutions that I'm proposing will not work in all situations, and approval from DOW is required as part of the Better Urban Water Management Framework. So in a sandy soil site, it's often tempting to maximise the yield and by controlling groundwater across the whole of the site. But as can be seen in this example, that can influence the groundwater dependent ecosystem. Modelling recently undertaken by the Department of Water as part of the Murray Drainage and Water Management Plan suggests that controlling groundwater levels by 1 metre below ground level can alter a groundwater-dependent ecosystem up to 600 metres away. Therefore, an EWR investigation must be undertaken to determine a suitable controlled groundwater level and how close this can be to the groundwater-dependent ecosystem. So in a sandy soil site, in an urban situation, this is often, this is probably the simplest solution, but it's often the most expensive. And as some of the other presenters today have noted, the cost of fill is increasing, and we are increasingly aware of the environmental problems associated with excavating and transporting that fill material. So in a sandy soil, you could also look at controlling the groundwater level using subsoil drains so that the existing hydrologic regime is maintained. So no fill has been used in this situation, which is an important note to make because some developers have used have filled the site unnecessarily and on the assumption that groundwater levels must be maintained. Groundwater levels only need to be maintained if lowering them will affect the groundwater-dependent ecosystem or if there are acid sulfate soils or other environmental factors to consider. This illustration only shows modification to the groundwater levels. However, other aspects of the hydrological cycle must be managed, such as the increased stormwater runoff associated with the development and the discharge of the subsoil drains. Perhaps the water that you get from this situation can be used in managed aquifer recharge situations. This arrangement is usually okay with soak wells, but take care when using septics and ATUs, as they have different groundwater clearance requirements, and they may have an impact on the downstream water quality. That's usually okay for councils and obtaining a Class A rating on your site. It's also okay for residential, commercial and industrial developments. So with sandy soils, with subsoil drainage and fill in an urban situation, this is a combination of the previous two strategies, where groundwater levels have been controlled using subsoil drains to the extent that the existing hydrologic regime is maintained, but the desired clearance may not have been achievable in that arrangement, so some additional fill has been brought in to maintain that clearance. So the previous caveats apply. Take care when using septics and ATUs or if acid sulfate soils are present. The previous situation is for urban situations, but in a rural residential development, it will be cheaper to only provide fill for the building slabs and for using septics or ATUs. The previous caveats also apply, and care must be taken to protect road foundations if you're not planning on filling beneath your roads. Alternatively, a stiffer slab may be used to avoid use of fill. However, there is a risk that groundwater may rise higher than the historic maximum level and cause nuisance waterlogging of gardens. This risk may be weighed up against the cost savings associated with that type of development. Oops, I'm sorry. Okay, I'll move on to clay soils. In a site with clay soils, there are less options for the developer to manage groundwater. In this illustration, I've assumed that a sandy layer above the clay layer and perched groundwater. This is often found in the areas south of Perth and northeast of Perth as well. There is less risk of modifying the hydrologic regime since the subsoil drainage is not effective in the clay layer, so trying to lower the groundwater level is futile. Now, in the next situation, the usual approach is to fill the site and optionally provide some subsoil drains to minimise the depth of fill. Alternatively, a stiffer slab may be used to avoid the use of fill. As with the same sandy soil solution, there is a risk that groundwater may rise higher than the historic maximum level. It can cause waterlogging in gardens and other parts of the development. So in summary, Development near some groundwater dependent ecosystems needs an ecological water requirements investigation to identify the suitable groundwater management strategies. Groundwater management strategies are site specific, but are usually based on soil types, groundwater clearance requirements, the type of the development, and how stormwater and wastewater will be managed.